We have seen that machine is going to store all the numbers using tiny electrical switches which has only two possible values on and off. We already saw how exactly int x is equal to 13 is stored into the memory. Not just 13, we understood how exactly other numbers are stored into the memory. We understood the conversion, right? So we can convert any number to binary and we will know the 32-bit combination for that particular number. There is something called as sign and unsigned. Sign means a number can have positive and negative value. That means whatever we are going to store into the memory, we need to identify whether it's a positive number or negative number. Unsigned means we will always have positive numbers only, no negative numbers. So our main problem was how exactly are we going to store minus 13? Now this minus symbol is creating the problem, right? We already know how exactly 13 is stored in the memory. So let's look at the unsigned numbers. Unsigned numbers has only positive numbers. That means you don't need to have a separate identification for positive and negative because you know that numbers are going to be positive only. That's why we have unsigned integers. So let's take an example of 8 bits. So you can store all the values from 0 to this particular number. This number is 255. So you have a range from 0 to 255 for unsigned integers. That's good. But when it comes to a sign, there are two possible combinations, right? A number can be a positive and number can be a negative. So we need another bit to understand whether the number is positive or negative. Why do we need a bit, another bit? Why are we wasting a bit? Remember, a computer has teeny tiny switches and these switches has 0 and 1 state only, that is on and off state only. So all the information, positive number, negative number, everything needs to be stored in memory in terms of on or off. Now there are only two signs possible, a positive number and a negative number, right? So positive number will be denoted by 0 and negative number will be denoted by 1. Now every single number is stored into memory using 32-bit. We are talking about the integers as of now. I'm just taking an example. So I cannot store the sign information to the right side because this is the place for the value. So I need to store sign information to the left side. I cannot store in between as well. That is going to create conflict between my number and a sign. That's why I'm going to store sign to the very last bit, right? I'm just going to store the sign. If the value of this particular bit is 0, then I will say whatever the number we have here, it's positive. If value of this is 1, then I will say whatever number we have by using these remaining 31 bits is going to be negative. So the problem was storing positive number and negative number into memory. Because we only have two sign, we managed to identify it using a bit. So now let's look at the 8 bits again. In unsigned, we managed to store values from 0 to 255. That's great. But when it comes to the signed numbers, this particular bit will be used to store the sign. So that bit is gone. That bit doesn't have the information about the value. So you have only these 7 bits to store the value. That's why you have this particular range, starting from 0 to 127. Why positive though? Because this bit is 0. If this bit is 0, then value is going to be positive. Now if this bit is 1, that means the value is going to be negative. So this particular range is from minus 0 to minus 127. Okay, so till now we managed to store the information of sign into the memory. No problem. Storing is not a problem. But if you store values something like this creates another problem. That problem is related to arithmetic. Now you have two different zeros, positive 0, negative 0. And that creates a huge problem, a different type of handling in arithmetic. In reality, we don't have two zeros, right? 0 is just going to be 0. But we have two different representation for 0 here. One is positive and one is negative. That doesn't work. That requires lot of handling when we deal with arithmetic. So we need another approach to store our negative number minus 13.